Hello, this is Nash from NB Network Lessons. Thank you for joining another session to charge up your brain, another physics session to stimulate your brain. Let's go ahead and get started without any further delay. My today's topic is under physics, lesson number 12, and we're going to solve an example in which we will see that we have an angle and we're going to try to find the x component of that angle and y component of that angle. So for example, let's say you're my friend and you come to my home. This is my home right here. You come to my home and you say, hey Nas, can I borrow your car? I'll bring it back in an hour. I'll like, okay, yeah, sure. You're a good friend. I trust you. Um, in order to get to my car, and there are a bunch of cars parked on the street, right? So I say, okay, as soon as you exit the door, just go 30 degrees and you will see my car. Now, is that a good way to let somebody know where you're parked? Usually when you go and park somewhere, you basically try to remember the coordinates, x coordinates, y coordinates, but you don't remember an angle. So I'm going to elaborate on that and show you something like that. So then let's see, we have this is right here my y-axis. This is right here my x-axis, right? X-axis, y-axis. This is my, let's say this is my home. This is my car parked right here, okay? And this right here is, this angle is 30 degree, okay? So I've told my friend, go outside the door, just do 30 degrees and you'll find my car. But there's a bunch of cars over there. It's hard. So now let's see if we can find this, represent this in an easier way. I want to make sure that my friend gets to my car. Okay, so I'm going to try to simplify and give him the coordinates, x coordinates and y coordinates. So let's say if we call this right here dx, okay, distance x, and we call this dy, distance y. All right. So now you got to remember your trigonometry. Right angle triangle. Okay, this is a right angle triangle. If you recall from your geometry, algebra, this is your right angle triangle. This angle is 90 degrees. This right here is perpendicular. This is right here is base, and this is hypotenuse. Okay. So in this case, I want to find dx right here. Okay. So dx is going to be from this point up till right here. Okay. All right. So now what I can do is I can say cosine theta, cosine of 30 degrees is equal to base over hypotenuse. Base is d of x, and hypotenuse is given. This distance right here is given, and it is 10 meters. Okay, so then cosine theta is equal to base over hypotenuse. So dx is base and hypotenuse is 10. Then I can find dx, which is equal to 10 times cosine of theta, 30 degrees. Okay, if you solve this, you multiply 10, cosine of 30 is 1 over 2. So then the answer is 5 meter. So you have to go from the point of origin, dx is 5 meters up till right here. Now we got to find the dy, which is right here. Okay, so how do we find dy? Now dy, if you recall from trigonometry, cosine theta is base over hypotenuse, sine theta is perpendicular over hypotenuse. Okay, so I can say sine theta is equal to perpendicular over hypotenuse. Okay, what is my perpendicular in this case? This right here, which is d of y. So then I can say d of y, first of all I can say sine theta, sine of 30 degrees is equal to perpendicular over hypotenuse, which is dy over 10, and then I solve for dy at 10 multiplied by sine of 30 degree is 0.866. So then d of y is equal to 8.666 meter. Almost, you can say 8.67 meters. Okay. So now, if my friend comes and I tell my friend, okay, that's fine, you want to borrow my car, go outside my home, open up the door, go straight 5 meters. Okay. Once you're there, then make a sharp left and then go straight 5 meters, 8.66 meters, 8.67 meters. Okay. Would that be easier, or just telling them just go outside my door and just take 30 degrees and you'll get to my car? I think this is easier. In this way, what we've done is that we've solved the x, d of x from here to here, which we said we solved, and we came up with dx 5 meter, okay? And then we solved for dy, which is 8.67 meters. I think it's easier when you tell the friend, go out of the door, okay? Go 5 meters straight or 5 steps straight, and then make a left and go 8.67, and you will see my car. So this is basically a numerical example to find dx and dy component. You could, represent this by saying go out 30 degrees, that's fine too. But I find it, the dx and dy component, easier. What do you think? Give me your thoughts. But thank you so much for watching. To all my physics lovers, stick with me. I will stimulate your brain, I will excite your brain, and hopefully we all will learn. Thank you so much for watching. Take care of yourself. Bye.